Thanks for coming here to listen to me. I'm just going to pretty much talk about sort of some stuff around scalability in testing in terms of volume, but also some of the blind spots that I see in terms of what is security, what is risk, and are we viewing the whole thing in a little bit of a skewed fashion. So firstly, my name is Eoin Keary. I'm the founder and CTO of EdgeScan, which is a sort of a vulnerability management SaaS based in Europe. I've been involved at OWASP for about, say, 12 years. I was on the global board up until the end of 2014. But let me move on and let's get to the interesting stuff. So, the thing with application security or risk in general, where OWASP is web application security or software security, and like a lot of people sort of default, that means websites. But it's the open web application software. The idea with OWASP, we think about it, is that nearly everything is made of software. So we've all of these sort of various sort of problem. We all these various solutions. We've in effect one problem. The one problem is that people are getting hacked. The one problem is this thing called risk, which is the chance of the likelihood of something undesirable happening. And we have this market which has come up with all these new things. Like, when I started this, there was no such thing as SAST. When I started security, there was no such thing as DAST either, actually. And then we have DAST, SAST, IAS, RASP, WAF, you name it, right? And then in addition to that, then we also have a thing called vulnerability assessment, which is like your host level scanning and stuff like that as well. So we have separated the market into a number of different pieces. But the problem is just one singular problem of how do I stop getting hacked? Or how do I develop and maintain systems such that I'm at least more strong than the other guy? Because hopefully then the other guy will get hacked and I won't get hacked, right? The outrunning a bear sort of adage. So if you look at it then, what is web risk? Is it application security? Is it host security? Or is it both? My view is the hackers don't give it a toss. If your vulnerability is in your web application or in your host level. And if you look at a lot of the statistical studies, and these sort of like the Verizon report or the Cisco report or the EdgeScan report, it's very much, you'll see that a very high majority of vulnerabilities found are actually non-developer related issues, right? So when we start to think about that, then we see that actually as a developer, a lot of the vulnerabilities in my system is probably in relation to code that other people wrote. It's nothing to do with me at all. So then we look at the point of view of risk. So if with any of these sort of levels, web applications, frameworks and components, web services, operating systems, network, protocol, port. Like you look at most of the web application studies in the last year, and they say SSL was the biggest vulnerability. If you look at the White Hat one or the EdgeScan one or the Cisco one, but SSL isn't really, if you think about it, it isn't our TLS. It isn't really an application security thing. It's more like a sort of a transport tunnel for data, and what we're starting to see is that a lot of the vulnerabilities we're encountering sort of are falling in between maybe two stools. If as security professionals, if we're only going to look at software and web applications and stuff, developers, which is the top layer here, you're going to wind up with sort of a huge sort of technical debt below that layer. And also then when you start to get into components and frameworks and the fact that it's maybe 80-90% of the code running on my application I didn't write myself, you start to consider, well then, there's probably a huge swathe of potential issues they may have. So the things around component management and rather than having just patch management, which is the traditional Oracle or Windows or whatever patching, we also have to consider frameworks like struts and Spring and all these types of things, which in effect also have vulnerabilities, but we don't patch. And one of the reasons we don't do that is because it's harder, because sometimes it's not it doesn't retrofit, it doesn't port very well. So we tend to just leave things as they are. So the other thing with sort of application security is the idea is that we have vulnerability analysis, application security, we have threat intelligence and endpoint security, and we have all these silos. And my view, my personal view is the market has driven us to have this siloed approach because all these are different products by different companies selling their own solutions. Oh, a threat intelligence solution versus an endpoint security solution versus, host versus application layer. And to be honest, if you're an information security person, like maybe a little bit more abstracted than an application security person, you don't really care how, in some respects, how the hacker breached your system. He breached it, and you realize you want to fix it. But the thing is that the hacker doesn't care if it's a web application vulnerability or a buffer overflow or a known vulnerability like a CVE. So I suppose in one way, I think we've made a fatal error in some ways, and it is market forces and stuff. But by sort of siloing these solutions and sort of in some ways maybe not being mutually exclusive, but certainly not being as sort of holistic as maybe they could be, I think that's a pretty serious problem we have in terms of trying to tackle the problems of information security in the first place. So this is a very cynical view of the world from Family Guy, which we also receive it in Ireland on TV as well. Probably a few seasons behind you guys, but the idea that, why cure cancer in a day when you can treat them for a long time and make a lot of money out of them? And if you think about it, a lot of sales pitch and spin and snake oil, etc. When people, particularly not people maybe with a lot of experience in the industry, but say people are looking for something to secure my web app, they're sold this solution and then it works sort of, and then they have to hire somebody to sort of manage that solution, and then it works, and then they have to buy another solution because the first one they bought doesn't fix everything, and it's very like that. Now that's probably a very cynical view of the world, but it sort of rings true to me anyway. And as I said, a lot of these are obviously just my opinions, and I'm happy for anybody to come at me and say I disagree with you and cry foul, because I think that's what makes these types of things good. So we've when we talk about segregated industry, you have developers versus security, admin versus developers, you have security versus admin, and we're all there doing our separate jobs. But in terms of, again, keeping hackers out of your systems, they don't care who does what. They have this monolithic system they just want to break into, pull your data out, shut you down, whatever they want to do, attack your clients, whatever that may be. And you sort of, it's a bit unfortunate, but we are seeing things move in the right direction in some respects, right? We have the idea of convergence with, developers and security and admin or DevSecOps, and DevOps is even more strong. I think DevSecOps or SecDevOps, as some people would call it, is sort of a little bit ill-defined, I think, still, and it's not as well-defined as DevOps. And the thing with DevOps is that, in my view, is that like the security view of the world is always a little bit behind what's pushing ahead in development. But we need to reflect that a lot better. So one of the things around convergence is we don't do is application security, host, component, and framework security, having this thing called Fullstack. We have guys that are SQL injection cross-site scripting gurus, and they're great at it, and they find everyone that exists potentially in a system. And you're sitting there with 0 cross-site scripts and 0 injection attacks. But then again, somebody walks in underneath your back door, commits a PHP known vulnerability by downloading some script from Millworm or something, and all of a sudden they're in anyway. But you didn't write that code, so why would you be concerned? If there was a remote command injection vulnerability in the version of struts you're using, again, I didn't write that. I wrote the code on top of it. So how am I as a developer meant to understand that problem? But then if I'm just a web security guy, am I even considering all these components and all these bits and pieces that we're actually using? My view is we're not enough. We need to do more. And not worry too much about SQL injection, cross-site scripting, but look at a system as an overall asset, I think is the word. So again, as I talked about, we have a bit of a divergence, right? And this could be blamed for industry analysts as well. Industry analysts put you in boxes. They put you in boxes and you're an AST, an application security sort of tool or an application security provider. Or you may be a vulnerability analysis, which is like, like a Nessus, Qualys type of thing, right? But the bottom line is, putting us in these boxes isn't going to help our problems, We actually need to figure out how to do this in a sort of a holistic way. So this is my view of a market-driven separation of our industry versus that risk isn't segregated in that way. Risk is the chance of something bad happening to something maybe you own. But our market has driven it in sort of in all these various little bits and pieces. So you have all this other stuff as well. Do it earlier. 1998 study from IBM labs in Zurich. Do it earlier, you'll save lots of money. Do it earlier, you'll find 20x better, more vulnerabilities. It'll be cheaper. And 20 years later, we still have the same crap, right? Just 20 years later, we're still talking. 20 years later, we're still talking about cross-site scripting. 20 years later, buffer overflows are nearly older than me, right? That's old enough. So if you think about it, there's an awful lot of malarkey and garbage in our industry, and people saying that their solution will fix X, Y, and Z. But the thing is that they're only tackling a smaller piece of the solution, as opposed to looking at, from a risk point of view, looking at something in sort of a more wholesome way, looking at all the layers, if you want to put it that way. And then, we also have the idea then of okay, so we're producing code quicker, we're changing stuff quicker in the DevOps sense. Where our systems are in a state of flux constantly, from the host, from components, from pieces of our open source on the client, and objects are pulling in from the client, from the server. And the idea, very much with Agile is to sort of spread bet that. So what we're doing is we have points of failure, probably more points of failure. So we're failing often, but we're not putting all our money into the sort of the very end piece, right? We're not putting all our money into sort of the very last sort of, like if it was a horse race, the very last jump, and hopefully we'll pass it, right? We're sort of spread betting, and that's very important. But we need to do that more in application security and security in general. But we've heard all that before, so I'm not going to. But it is something that we need to do, but not do it only for web app security. You need to do it for a lot of other aspects of your systems in general. So we have the idea of continuous integration, continuous deployment, test-driven, continuous. Everything's continuous. It's moving. It's not. We're not waiting for things to happen, at the end anymore. We're pushing new code every day. How do we track that? How do we maintain that? How do we actually get some clarity when we're pushing code that we're not pushing vulnerabilities? Or if we're doing a reasonably good job and we start pushing code and systems and deploying new systems in general, not just applications, on a much quicker way in the cloud environment. So we're instantiating new instances all the time. We're pulling them down. We're adding new services. We're taking them apart. And all that. And we're breaking these into various services as well. And in the same time, how do we maintain that sort of level of diligence or level of rigor when we're looking at it from a sort of a security point of view? So the idea of continuous security, as you know, is it's keeping up with development. It's the idea is very much to try and catch bugs early and try to match pound for pound what development is doing. That's hard. There's normally about a 10-to-1 ratio between developers and security people, right? So it's very hard to do that. But then again, if you look at it in the old way, what we've been doing for years is we do a 2-week penetration test on an enterprise system, because that's how much they'll pay for internally in terms of time, or in terms of a commercial agreement with a pen testing firm. And you're giving this guy or these couple of guys 2 weeks to, in effect, test 10 man-years of development work. It doesn't make sense anyway. You can't do it. We've been doing that for years. Here's 2 weeks. Go and test, every data flow and every nuance and every use case within this enterprise application, and you've got, 2 weeks, 4 weeks, and compared to 10, 20 man-years of effort actually gone into building the system in the first place. It doesn't work. So then we talk about the idea of hosts and service and frameworks, and sort of, okay, what are they? Well, the thing is, something you'll find. All right, so when I started doing security a long time ago, they were saying, don't worry about client-side scripts and client-side security. It's not that big of a deal. Everything should be done on the back end anyway. And then we have the idea of DOM cross-site scripting came out, and the idea of, with Angular, if you have a richness now in the client, such that we can't say that anymore. But the thing is that we're using all of these sort of frameworks, and in effect, if you think about it, like an awful proportion, as you mentioned, is sort of not written by you. A high proportion of people don't have any way of monitoring component security at all, right? So, and then, a lot of people don't have an open source policy. So if you have developers and the lead developer says, let's use this plugin, it's pretty useful, and okay, it works, let's go for it. But like who wrote that? How good is it? Is it secure? It could be even a very, very commonly well-used component, but that doesn't mean it hasn't got some big issues in it, right? So, the idea is that it's when you start looking at it from a risk point of view, it's not just the code you guys have written, it's actually the actual components you're using as well to save you time in building your system. Examples of these will be, this as of October, 7 million downloads since the vulnerability discovered in the spring. Struts 2, another one, CVSS score 10, it's pretty high. 180, 200,000 downloads of that version of Struts, even though this vulnerability was known. It doesn't really mean, though, that these are being used in production systems. There's no way, I think, of tracking that. But what we can say is that why would you pull down a piece of code if you actually knew that there was an issue with it? Why would you even consider deploying that or using it? Because we don't have component management or component security, so we're not sort of too concerned. Sure, everybody's using it, let's download that, it should be fine. And let's focus on contextual output encoding and parameterization and stuff like that in our SQL injection and in our cross-site scripting and that type of thing. But then again, some of these, for example, this is a remote command injection vulnerability, which it's there, you didn't do it, but you can still get rogered from in effect, having this enabled in your system. So, we every year with EdgeCamp, we have a vulnerability stats report. It's like every other one. And to be honest, year on year, it doesn't change that much. But one of the things we did see is that 63% of all the vulnerabilities were not really developer related issues. So it's obviously everything's made of software, but it weren't the developers that are actually using it. They were more like sort of operating system CVE components, misconfiguration issues, that type of thing. So it wasn't actually code. It wasn't OWASP top 10 sort of the top 3 things and that, like injection, cross-site scripting, whatever. It actually a large proportion of issues can be removed by just simply doing something like adequate patching and component management. So I suppose when you come to that conclusion, then you can say, well, if I'm not doing component vulnerability management, am I doing AppSec at all? Or am I just conveniently blocking that piece out? Do I want to ignore that because it's such a pain in the ass to tell your developers they have to upgrade their versions of Spring? And it's actually not as simple as dropping a new jar file or a WAR file into the server, because there's lots of retrofitting and deprecated methods and all this type of stuff, right? So it isn't, I'm not saying this is easy. And then if you're not doing full stack, which is, in my view, is the idea around host operating system, your poodles and all the shell shocks and all that stuff we had last year, your cross-site scripts, your client-side security, your JavaScript, your output encoding, and everything else in between. If you're not covering all of that in some way, are you doing security at all? Are you just focusing on what you think you're comfortable with? Because hackers don't care what you're comfortable with. In effect, if they want to do something, and particularly targeted attacks, if they want to get in, we have a really strong AppSec team and we use all these cool tools. Yeah, but we're just going to come in via your open RDP port or something stupid on your firewall, right? So how do we sort of manage this? So how do we fix it? How do we fix this problem? How do we even attempt to address it? So this is some of the experience we've had through the fact of managing thousands of assets for many years with EdgeCamp, but also working with sort of agile teams and teams that deploy code very frequently. Industries like retail and gaming and those types of industries, their websites are changing all the time, as opposed to financial services websites that don't change as much. change can give rise to bugs, and bugs may give rise to security issues. So if you have something that's changing a lot, you may actually find that there will be a lot more vulnerabilities. That sort of makes sense, right? So we can scale, right? First of all, we can do that. We can scale in terms of automation of the of assessments. We can do depth, coverage, and breadth and rigor, and we can do all of those things, and we can do them well. And tools are very good at finding typical stuff. Tools now are very good at finding cross-site scripting issues in many cases, not in all cases. There are some nuances there, particularly like the stuff like the DOM stuff can be a bit more difficult. So stuff with Angular can be a bit more difficult. But say in general, even if we got rid of all the traditional reflected cross-site scripting issues, the idea is that tools can do that pretty easy. We can scale by virtue of having automation. So that can be stuff like event-driven or scheduled automation. So as we check code in a continuous integration environment, as we check in new code, as we do certain events, those things in effect will trigger something like a build script, which will then it triggers a number of cases. So everything from using Selenium to drive tools via a proxy, sort of a burp or an OWASP Zap sort of thing, to using sort of commercial grade solutions which are out there as well. And all of those things can be hooked into build servers and whatnot, Jenkins, Hudson, whatever that may be. Also, in terms of automation, we use these things, and people use them, or they're built their own, like Chef and Puppet and stuff. And the idea of being able to control builds in an automated way. So if something falls out of kilter, you can in effect, or needs a patch, it can be done fairly automatically. In the cloud sense, we won't patch anymore. In the cloud sense, what we'll do is we'll have immutable instances, baseline instances. We'll just rip the old one down and rebuild and push a new instance up. The concept of patching in the cloud, I think, it's not really putting band-aids or anything. It's actually just ripping the whole thing off and sticking in the new one. But that sounds great, but the thing is with automation's very good at detecting technical vulnerabilities, right? So misuse of code, misuse of implementation issues, coding bugs, things like that, right? Which is pretty much a lot of the stuff we talk about on a day-to-day basis, the top 10 stuff, etc. Automation isn't so good at this type of stuff, right? Business logic, our backdoor stuff. The idea of having hard-coded passwords and stuff like that. Sometimes, particularly say Dast wouldn't be able to find a backdoor, but if you knew what the URL was and what the parameter value would be, that would invoke a backdoor. But if you don't know it, you can't test for it. And also provide risk measurements, because most of these tools will say every cross-site script is a high risk, and every SQL injection is a high risk, and anything that has a sexy 3-letter acronym is a high risk, and you'll have read all over. But then when you get into it, you go, all right, well, what's the likelihood of leveraging this technical vulnerability against my business? What's the likelihood of this actual issue being used against our business in a real way? Because finding vulnerabilities and going from vulnerability to exploit is actually not as simple in many cases as you might think. It's easy to find cross-site scripting, but then show me to use it to steal somebody's credentials, log in and take all their money. That's what I want to see, So tools don't understand business context or risk. So generally they just have a default value for a particular vulnerability type. So if you look at it that way, then we start to fall off a little bit in terms of automation. We can do some stuff with automation, but we can't do everything with automation. So this is like my view. Don't know if anybody likes the Beatles, the Yellow Submarine. These guys are called blue meanies, and they're sort of pretty mean and blue. And these guys, in effect, are sort of the gremlins in the system. And what I'm sort of talking about is what are the types of issues which prevent us just throwing automation at stuff? Where do we actually not? Where can we do lots of good automation and get it working? And then so when we things constantly changing, be they code releases or host environment changes or cloud changes, whatever they may be, versus where can we not do that so well? So the anti-scale, in my view, is things like risk, information versus data. The idea of having data doesn't mean it's information. It's only information if it's useful. The idea around human decisions and intel. So in certain cases, again, it's all about risk. technical constraints, upstream compensating controls, all that type of stuff. Automation isn't very good at understanding. And what we're here to do is not find vulnerabilities. We're paid to reduce risk for our organizations. We're not here to find cross-site scripting issues. That is not your job. It's good to find them and you feel great about it, particularly the first one you've ever found in your life. We all remember that day. That was fun. But the thing is that we're here to try and stop people damaging our business or whatever we're trying to protect. So what does the anti-scale mean? It means, we have lots of new types of languages now, and a lot of them aren't sort of heavily typed, strongly typed, which can be hard for things like SAST, because SAST can understand what context the parameter is in. APIs and RESTful APIs, I think one of the things with that, is there isn't very many tools that actually do RESTful security very well. So if you want to scale, you may need to write your own one, or you need to figure out, because when you actually think about how to protect RESTful APIs, it can actually be a little bit more complicated than you were initially taught. And the other thing around this is that we also have, if we're producing code, we're deploying, our idea of having a manual test for every time we produce code, we can't do that anymore. We can't scale. So the idea is manual testing doomed in some respects, in the way that, no, your job won't be to find cross-site scripting things anymore. Your job, in effect, is going to be to maybe focus on things like behavioral logic and business logic, and let the automation get rid of like all the technical vulnerabilities that are easily found. I think that's sort of what we're going to wind up doing anyway. So how do we fight this? The idea would sort of, how do we fight this anti-scale? How do we scale when we have problems? Well, some of the things we need to do is do rule tuning. So getting a DAST or a SaaS tool and putting it into a pipeline to develop a product or piece of code over many iterations, we need to tune the rules. We don't want to fail builds, because developers will get upset, which is they rightfully should do, because you're failing builds based on false positives. You won't be very long in your job if that happens enough. We also need to remove white noise, or just noise in general, being sort of these. All of the tools do it, and we're all compelled to do it. Is let's have so many rules, because we have more rules than the other guy, and we have all these theoretical sort of issues. And these vulnerabilities aren't worth even getting out of bed for or worrying about, but they're tested for by all of these tools, because it makes the reports look bigger, etc. And let's get rid of those things as well. And then the idea, what we're talking about, is real security, real risk. What's the risk of me actually getting clobbered versus best practice? It's best practice to use a particular random number generator to generate a random number. Okay, that's fair enough. That's a catch. But then you realize, well, actually, the random number generator is just to determine how many random seconds the next ad in your banner will display. So it's not an issue. So it's that sort of contextual thing. And then what we also have to think about is scale. So the idea of, when we test, do we test everything every time? Or do we sort of implement some form of delta analysis, which is the idea of difference analysis over time, which is very, very effective in terms of scaling. So with SAST, analysis without runtime, right? It's good. It's more than just tooling, though. SAST is very much around the idea that we have to, it's the management lifecycle that's challenging when implementing SAST in a continuous integration environment. It's the idea that rule management and tuning and false positives are all very key. Again, what we want to do is avoid failing builds. We don't want Jenkins to send an email to the team lead saying that the issue was failed because of a security issue that actually doesn't exist. And also, SAST can't cover all the issues, right? It's not good at certain things. These are some examples. Storage of, you read them yourselves, but a lot of them are around logical or contextual. So it's data, it's storage and transmission of data, but SaaS doesn't know it's confidential or not. Logic, it's quite obvious. And then data privacy and retention and stuff, because it obviously doesn't, again, understand what the context of the data is it's looking at, or where those parameters are going in the code. So the thing around this is, this is sort of, you would think the sort of the flow chart is put code in scanner, press red button, results come out, go and fix. But then when you start to build it out, you say, well, actually, we can't do that. We have a continuous code. being developed. We have a number of toll gates, so we're going to check in the code here, and then we're going to see if it's a fail or a pass. So if it's an issue, if we're going to fix the code, well then we'll fix the code. If we're not going to fix the code, there's either a reason for it because we don't think it's a big enough risk, or it could be a false positive. It's a false positive. We need to tune the rules and remove that false positive, tune the rule a bit, and then run it again, such that and over time you'll see that you'll start to get these false bill fails and such things, right? So it's not just again pushing code into this thing that runs itself over your code. It's the management overhead as well is reasonably big. But it's not impossible, and actually it can be done probably in about 2 weeks for any sort of sized team. We've done numerous times for 300 or so size development teams using various languages. So the idea with DAST, right? So there are some management pitfalls as well with DAST. It's just that the coverage depth with DAST. So this is like we're moving from SAS now to DAST, which is another piece you can do in CI in terms of scalable. DAST primarily it's a great way to talk about DAST. It's in effect trial and error testing. You're just going to send something hundreds of requests, and hopefully you will react in a weird way for some of them. It's not good for logical ones as well, right? And then we also have another piece of the puzzle, which is vulnerability assessment, which is our typical host environment, and how do we maintain that if that's going to change all the time? So what we find with this in terms of doing this at scale and volume and frequency is the first assessment is generally going to be a difficult one. And then after that, subsequent assessments then will be easier because we're going to use a thing called delta analysis in effect, or consider using that. So we're going to start comparing the current vulnerabilities or the current findings with the most recent last one. And if you do that, then you start only to focus on difference, which makes you extremely scalable in terms of your pipeline. And then we have our component security, mentioned this already. But component security, like host, is very unpredictable because you can't tell when one of these vulnerabilities will be discovered, right? So it requires sort of continuous, scanning and that type of thing. All right. So when we get all this, then we need to do things like delta metrics. And what we're doing here is we're looking at change. And there's a few reasons for doing this. Metrics are really important, and you've probably heard that already the last few days. And they're crazy important for a number of reasons. For us, it's because we can start to establish things like root cause. If establishing root cause, we can establish that the vulnerabilities are finding are maybe patching issues. Okay, we need to figure that out. Are they more code-based issues? Okay, what tech stack are we finding it in? We're finding it in sort of maybe in the in the code of the framework. What layer, app or host? And then in effect we can then start to home in. Is it sort of all PHP? We're finding a very high level of cross-site scripting issues in PHP, and therefore we can sort of focus our training and our awareness on those issues with that development team and so on. And then you can start to measure improvement, because if you can't really improve what you can't measure. So very much this type of thing is very, very important in order to get right. And you can most tools. And sort of CI or continuous integration or agile pipelines where you would implement you would be able to get this type of thing fairly easily, and then you stack it up over time, and in effect then you start to get a very good picture of where are your vulnerabilities, what layer, how common, and then in fact trying to figure out what do we need to do to try and maybe push that, improve that a little bit more. Okay. The other thing around this is around continuous change is continuous asset profiling. So this is the idea that we're going to constantly monitor. It's like having an asset registry of your estate. And it's in what we're going to do is we're going to detect change. But this is like a sort of a passive scan. It's not vulnerability scanning. It's very much looking at, okay, how many live IPs do we have? How many dead ones or new ones have I had since the last time I looked here? And we're doing this on sort of an ongoing basis. What services have changed? Has somebody opened a firewall? Has somebody deployed? Now, what we find, particularly with larger development outfits, that the developers may, and it's by no fault of their own, but they may deploy, or maybe it is by their fault, to be honest, but maybe they deploy dev environments out onto the public internet to test stuff, and then they leave them out there. And then in effect, it's there could be some, non-fit for purpose code in that environment, which shouldn't be sitting out on the internet. So in effect, this idea is to detect change. You can get into it and say, well, actually, you could detect rogue deployments being exfiltration points for networks, stealing data, advanced persistent threat, and all that malarkey. But bottom line, it's not. It's more for me. It's more around just saying what's changing in my external environment on an ongoing basis, and then you can couple that as well with all the other stuff we looked at already in terms of metrics, and you start to get a very, very good picture of what's going on in terms of your overall digital estate, I suppose. So the idea with delta analysis, I mentioned this already, but it's the measure of change. So what we do when we do delta analysis is we look for closed issues. So these are issues in effect that were there last time, but when we did the most recent assessment, they're gone. So that would flag, because that issue is changed. A new issue, a false positive. Obviously, we can't flag false negatives because we don't know they're there. Otherwise, there wouldn't be false negatives. So, in effect, what we're talking about is that all we need to do is focus on closed issues, new issues, to verify they're closed, to verify these is actually a new issue. If it's not a new issue, it's an FP. If it's an FP, we mark it an FP. And then the next time we come back to it, our system has memory to say, oh, I know this is an FP. It was verified already. And I know, so I won't waste the analyst's time anymore. And in doing this then, even though there could be 200 vulnerabilities, you may have only to look at 8 or 9 of them or 4 or 5 of them, because all you're looking at is change, which is it's pretty cool. Simple idea, but it's very, very effective. The other thing around this is in terms of continuous integration, is breaking the testing into little pieces, because that's what our developers are doing anyway. Implementing incremental testing versus full regression testing, and the idea of having early and often testing, having a continuous. And also, one of the things you'll find is people say, well, if this is continuous security testing, I want it done every day. And the duration of how long it takes to do a test, because some applications can take quite a while to actually cover off. That is what defines the frequency of the test as well. So you probably need to bear that in mind. If you're doing incremental testing, obviously your frequency can increase much quicker as well. So what we can't do very well at scale, just to finish off, is the idea that business and behavioral testing can be difficult. I'd like to see that technical security is covered off by tools. Technical security is found using machines, technical security being coding errors. And then I'd like to see our pen tester fraternity focus more on behavioral and business testing, because that's more where the juicy stuff is anyway. In my experience, we've simulated stealing a lot more money with business logic issues than we have with cross-site scripting. That's where the juicy stuff is, and the better fun stuff as well. It keeps your job interesting if you're a pen tester. Finding cross-site scripting for the 5,000th time doesn't fulfill people that much anymore, I think. So I think it's something that I'd like to see push ahead, so we don't have to talk about cross-site scripting anymore, because if you look at it, it's just extremely boring subject at this point. Most people would think anyway. So pushing towards technical vulnerabilities rooted out using technical methods, push from chasing top 10 issues to behavioral and logical flow, using the tooling and using the metrics and the delta analysis and all that stuff, and the full stack approach, because as I said, it's not just web security. That's the issue here. In terms of risk, in terms of protecting your business, it's also the stuff below layer 7. Constant Flux does require constant assessment, but again, if you're doing it and you're doing some form of delta analysis and not full regression testing or whatever, it's achievable. We've done it. It works, and it's very, very effective. I think the idea of having a point in time assessment, hey, can you come in and do a 5-day pen test on this app before it goes live, isn't really going to last for much longer. I think businesses want security to match the way they actually write their code. So we need to adapt to the way code has been written. Now, we are to a certain degree, but there's a lot of work to be done. So that's pretty much all I'm going to say, and it's just some time for lunch anyway. So Anybody any questions at all before we call it a day here? Anybody? No? We good? Okay, cool. Well, thanks for your time. Much appreciated.